lesson 12.6, combinations. A combination is a group of items whose order is not important. Remember, it's very similar to permutations where order is important, but combinations order is not important. Example 1, a pizza shop is having a special on large pizzas with 2 toppings. You want to order your pizza with 2 different toppings. You can choose from pepperoni, sausage, green peppers, onions, olives, and mushrooms. How many different pizzas can you order? Let's start by listing all possible pizzas with 2 different toppings. Okay, so we actually are going to list this. And obviously there is a different way to do this than just listing it all the time. But you want to, once you list it, and you can write this down, you want to cross off the ones that have the same type of pizza. For example, the PS is pepperoni and sausage, just like sausage and pepperoni. It doesn't matter what order you put it in. We're going to cross off the ones that are the same. That's what they did here. You can see it's kind of the 1/2 of the list. So all the ones that we have are circled. That is a total of 15 different types of pizzas. In example 1, the complete list shows the number of permutations of 6 items chosen 2 at a time. How many items would be in the complete list if you had to choose 8 toppings? Again, it shows the number of permutations, 6 items chosen 2 at a time. Again, we can show this by subtracting. 6 minus 2 is 4. This is 6 times 5. And then we can take off the 4 factorials. So you have 30, and you can see that all of this was 30. But then we took half of it off, and that was 15. So how many items would be in the complete list if you had to choose from 8 toppings? So we get 8 toppings, permutation 2. 8 factorial over 8 minus 2 is 6 factorial. So 8, 7, we don't need the 6 factorials because they cross off. 8 times 7 is 56. Combination notation is very similar to permutation. You take the number of objects, n, taken r at a time, and then divide the number of permutations of n objects taken r at a time by r factorial. So n combination r, and you may see it look like this, by the way, is represented by permutation, n permutation r, divided by r factorial. To set this up, you have 8 permutation 6 divided by, and this is the r, 6 factorial. Let's try that for A. 7 combinations 4. We set it up as 7 permutation 4 factorial. That means that we're going to have this in my top, which is 7 factorial over 7 minus 4 factorial in my numerator. We can simplify that to this because this becomes 7, 6, 5, 4, and then 7 minus 4 is 3, so the 3 factorials cross off. Let's put this simplified version of the permutation in the numerator, over 4 factorial. Expand the 4 factorial and divide out common factors. So let me show you how they divided out common factors. You can see they took away the 4's because 4 and 4 are the same. 6 is actually 3 times 2. So if you take 3 times 2 away, you're also taking away the 6. So what you have is 7 times 5 is 35 over 1, which is just simplified to 35. For part B, you're going to have 10 permutation 5 over 5 factorial. Let's simplify the permutation. 10 factorial is 10, 9, 8, 7, 6. Now I'm going all the way down, this is 5 factorial, to 5 factorial. That's all over 5 factorial, the 5's cross off. 5 factorials cross off. Put that simplified version in the numerator over 5 factorial, expand the 5 factorial, and then divide out common factors. Okay, one more time. Here's what they did. 10, 9, 8, 7, 6 over 5, 4, 3, 2, 1, because that's 5 factorial. Let me show you how they divide out common factors. I'm going to take the 5 and, well, you can actually do 10 and 5, both divide by 5, so you're left with a 2. 9 and 3, both divide by 3, so you're left with a 3. 8 and 4, both divide by 4, so you're left with a 2. 7 doesn't do anything. 6 and 2, both divide by 2, so you're left with 3. Multiply straight across, you have a 1 in the denominator, so it's 252. Just so you know, your calculators do help you solve these problems. And I'm going to show you how to do that now. If you are using one of the black Casio calculators, here's how you would solve this problem. Let's just look at number 2. First thing you want to do is put in 5 into your calculator. Then you hit the black button that says Shift. Then you hit the 2 button, and you can see the 2 right above it has an NCR. Nothing changes on the screen, it just says 5. Hit the number, because that's what R is. Hit equal, and you should get 10. By the way, you can see that the 2 is NCR. The 1, let's talk about the 1 first. The 1 button right above it, if you hit Shift, is permutation. Also, the 3 is a factorial. So I could put in, if I want to do 5 factorial, I can put in 5, hit the Shift button, and then hit the 3, which is the factorial, hit equal. Actually, don't even need to hit equal, and it gives you 120. So you might want to write this down somewhere so you remember it. But pause the video, try 3, 4, and 5, now that I showed you how to do it that way. So, 8 combination 2 is 28. 9 combination 9 is 1. 7 combination 1 is 7. In example 3, you need to tell whether the possibilities can be counted using a permutation or a combination. Remember, permutation order is important. Combination order, not important. And then actually solve the problem. Let's look at A. A flower shop sells red, pink, white, peach, and yellow roses. You want to choose 3 of these colors to make a bouquet. How many different bouquets can you make? Now, is the order important? I would say that the order is not important when you're choosing the flowers, because it doesn't matter where in your bunch of flowers the peach is or the yellow is. As long as you picked a yellow and a peach, it doesn't matter where it is. That means that it is a combination. And we would use, let's see, there's 1, 2, 3, 4, 5 choices. You're choosing 3, 5 combination 3. 5 combination 3 gives you 10, so there's 10 different possibilities. For part B, because the cheerleaders, 6 cheerleaders are going to form a pyramid, in how many different ways can the cheerleaders be placed in the pyramid? Well, because the cheerleaders can be placed in different positions in the pyramid, order is actually important here. Because cheerleader A could be on the bottom left-hand side, or she could be on the top. So that would be a different formation. You can evaluate this by taking 6 permutation, and how many cheerleaders are you using? 6. 6 permutation 6. You can solve this, which is 720 different ways.